This is 2005 question 6 part 2. Part 2 of my solution anyway. The period of a satellite is 380 hours. Calculate the radius of the satellite's orbit around Saturn. And do we know the mass of Saturn? We do. The mass of Saturn is 5.7 by 10 to the 26 kilos. And the universal gravitational constant is 6.7 by 10 to the negative 11 Newton meters squared per kilogram squared, which is a mad old unit. Okay, so we're just going to use the formula we just did, which is what was it? T squared equals 4 pi squared or cubed over gm. We're looking for the or. Okay. We know everything else, but what I do want to do is make sure that the hours. Oh, well, okay, let's rewrite it first of all. So or cubed is t squared gm divided by 4 pi squared, which means that I'm just going to cube root it. Okay, so or is the cube root of t squared gm over 4 pi squared. Okay, I have all of these. What I just need to do now is substitute them back in. So this is the way we should be doing solutions all the time. Please write down your formula, then put in your stuff. So it's 380 hours, which means it's this many seconds. I'm going to square that. Then I'm going to multiply it by g, universal gravitational constant. Then I'm going to multiply it by m, the mass of Saturn. 5.7 by 10 to the 26. And I'm going to divide that by 4 pi squared. And it is a cube root, remember. Cube root, stick in my fraction. So 380 by 3600 times 6.7 by 10 to the negative 11 times 5.7 by 10 to the 26 and divided by 4 times pi squared, and I get an answer of 1097886. What's that? That must be meters, right? 1.05 meters. 1, 2, 3, 4, 5, 6, 7. That is different from what the marking scheme is giving me. Did I forget to do something? I did. I'm an idiot. I forgot to square it. Okay, close that bracket, square that, because I'm squaring the period, which gives me a much different answer. Sorry about that, everybody. So the radius is actually 121876753 meters. Okay, what's that? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1.2 by 10 to the 9, which is what the marking scheme says. Awesome. Okay, cool. All right. The satellite transmits radio signals at a particular time. The satellite is 1.2 from the Earth. How long does it take the signal to travel to the Earth? Okay, so we're just doing distance over time. Well, how long? Yeah. No. We're doing distance over speed. Okay. So we're told that the particular time the satellite is 1.2 by 10 to the 12 is the distance away. The speed is the speed of light, 3 by 10 to the 8. So the time taken is just that. 4,000 seconds. Okay, it is noticed that the frequency of the received radio signals at the satellite orbits Saturn changes the satellite. Okay. The frequency changes due to the Doppler effect. Explain why. As the satellite moves away from Earth, the frequency is decreased because it's moving away. It's kind of got a step between it every time the waves go, so you get like it's stretching it out. As the satellite moves towards Earth, the frequency, I should be using the word appears to be. Appears to be increased. Oh, sorry. Okay, c'est ça.